This is a Math 1 lesson summary video for the task titled Texting by Numbers. This is a Solidify Understanding task. The purpose of this lesson is to describe data distributions and compare statistical representations. So in this task, we examine the number of text messages that Rachel and her friends and her mom sent for each day of a month. If we skip down to part 3, the data is listed. So Rachel's mom sent 150 texts on one day, 5.5 texts on one day, 6 texts on one day, 5 texts on one day, and so on. And this is the number of texts that Rachel sent. So just by looking at the data before we do anything with it, it looks like a lot of the numbers for Rachel's mom is considerably less than a lot of the data values for Rachel. So let's take a closer look, and I'm going to use Desmos to graph this data so we can get some more representations of it and get a closer look at it. So in Desmos, I've already typed in the data. So I just did M for Rachel's mom, then equals, and then I used this bracket, and then I just typed in all the data values. And then I did the same for Rachel here. So let's create some data representations. So I'm going to create box plots and histograms. So to create a box plot, you have 2 different ways you can do it. One is you can show the keypad here, and then go to functions, and then under distribution, you probably will have to select this distribution. This is where you have your different ways of representing one variable data. So with the box plot, I'll click on box plot, and then I want to use to graph the mom's data first. So I'll just put an M, and there's my box plot. If I'm unhappy with the way that it's viewed, this button right here, this is a zoom fit. If I'm still unhappy with the way the window is, I can always go to the wrench and adjust it myself. So I can change this to go to -25 and say 200. And I can see here that this box, I have my minimum and then my first quartile, and then the median or second quartile is really close to that first quartile. And then I have third quartile, and then my maximum is up here. So I'm going to compare that to a box plot. This is the other way. You can just type box plot right into the entry box here. And I'll do R. And this is let me hit the zoom fit so I can see it. So this isn't a big surprise. We knew that Rachel sent more text messages, so her box plot is further along on this x-axis. It's kind of hard to see when they're overlapping like this, so this offset, I can put in a number and it'll do a vertical translation. It shifts it up, so that way I can see them a little bit better. All right, so next I'm going to do the histogram. So just like with the box plot, I can just type in the word histogram, and I'm going to do the mom's data first. And the bin width, that's how wide you want your bars to be. I'm going to set mine to 5, which means it's really counting by 5s. I'm going to align to the left. So this first box right here is including data from 0 to 4 texts. This next box is including data from 5 to 9. And so it's counting by 5s. So it's set to the left. So for this next histogram, I'll go the other way. So I hit function, and then under distribution, I'll do histogram, and I'll do Rachel's, and I'll set her bin width to 5 and make sure it's centered to the left as well. So if I look at these separately, I can see there's a little overlapping right here. So if I turn hers off to get a good look, and I want to make sure I do zoom fit to make sure I can see all of the data over here. So I have 2 histograms and the box plots. I can put the box plots on it also. So let's take a look at the shape, center, and spread. So if you're asked to describe a distribution, it's wanting you to describe the shape, center, and spread of the data. So the shape I have listed here as skewed to the right. So we're going to talk about Rachel's mom's text first. So skewed to the right. So that means that there's data values that are on the right side that are making the shape have a tail out here. So on the box plot, you can see this long tail. It's the same if you were to trace over this histogram with a smooth curve. You'd have to come all the way out. So most of your data is over here to the left. You have something that has pulled the distribution to have a tail over at the right, so it is skewed to the right. Now the center is talking about the mean and the median, and this shouldn't be very surprising because with a number that's a lot higher than all the others, that will make the average or the mean be a lot higher. Now to calculate the mean and the median, I did that with Desmos. All I had to do was ask Desmos to find the mean for Rachel's mom and the median for the data that I titled M for Rachel's mom. For the spread, that's the interquartile range and the standard deviation. To get the interquartile range, I just had to subtract the third quartile minus the first quartile. And to get the standard deviation, I again used technology. To get a quartile, you can type in the word quartile, tell it which data set you want to use and which quartile you want. Or you could go to Functions and Stats and Quartile, and then tell it which data set to use and which quartile you want. You can also do this all in once since you want to get these values to be subtracted. I can say to quartile 3 minus quartile 1, and it'll do that subtraction for me. For standard deviation, under Function Statistics, it's STDEV for standard deviation. And just tell it which data set to use. So these values do make sense. Standard deviation is a measure for how close the most of the data is to the mean. So if you have these extreme value points, it would make your standard deviation much larger. And our quartile range is more resistant to those extreme data points because it's looking at that middle 50% of the data. So then if we take a look at Rachel's text, this shape I have listed as skewed to the left. So it looks like it almost could be normal curve. It looks like it's almost symmetric. But if you look closely at the center, you can see that the mean is actually lower than the median. So there are some low values that have brought down the average. So those extreme lower values that have brought down the average is what makes this shape skewed to the left. So remember, spread gives you a measure for how much your data varies. So with the standard deviation being so large, it's telling us that our data really does vary from the mean. Interquartile range, remember, is more resistant to extreme data values. So it's talking about this middle 50% of the data. So the next thing that we should do is check for outliers. So we already kind of have an idea that this data value out here, the 150 is an outlier. Let's see if there are any more outliers for Rachel's mom, and let's see if Rachel has any outliers. Here I have the first quartile, third quartile listed for both data sets and the interquartile range because we're going to need this data when we check for outliers. So the rule that we'll use is 1.5 times the interquartile range IQR. So let's start by applying this rule. So for Rachel's mom, we have 1.5 times the interquartile range, and her interquartile range was 10.5. So 1.5 times 10.5 is 15.75. What we do with this value is we subtract it from the first quartile and we add it to the third quartile. So what this is telling us is any time that Rachel's mom sends more than 31.25 texts or less than negative 10.75 texts, which doesn't make a whole lot of sense. So we'll just talk about any time she sends more than 31.25 texts, it's considered an outlier. So it's unusual for her. When we go back to our data, we can see that at different times, Rachel's mom sent out 35 texts and 150 texts. So those data values, however often they appear, are considered outliers. If we return to Rachel's data, so again, we have 1.5 times the interquartile range. So the interquartile range is 19. 1.5 times 19 is 28.5. We subtract that from the first quartile and add that to the third quartile. This means that anytime Rachel sends more than 81 texts or less than 105 texts, it's considered an outlier. When we go back to the original data, we can see that there are different days where she sends 80, 85, 70, 36, and 275 texts, and those are considered outliers. They are beyond what is normal for Rachel's text messaging. So to summarize, when you're describing center, that's talking about the mean and the median. Those are measures for center. The median is more resistant for outliers, so the median would be a more appropriate measure for center if there are outliers. For describing spread, that's interquartile range and standard deviation. Interquartile range is less affected by outliers, so it's a more appropriate measure of spread if there are outliers. When you're describing the shape, there are many different ways that you can do that. If your data is evenly spread out, then it's considered uniform. If it has one peak, then it is unimodal. Bimodal, if it has two peaks, and multimodal, if it has more than two peaks. So your data is normal if it has this symmetric shape. And if it has this perfectly symmetric shape, then the mean would be equal to the median. It is skewed to the right if your data takes on this shape. And in this shape, you would have the mean greater than the median, because you would have some large values that would pull that average up. And skewed to the left if you have this tail end of your data over here to the left. And that would mean you would have some low data values that would make your average come down, so the mean would be less than the median. All right, that's it for this video. Thank you for watching.